Hello, welcome to my intro to Spring for True Beginners. In this video, I will be going over the basic concepts that the Spring framework is built upon. In the future videos, I will be presenting on various Spring modules such as Spring MVC, Spring Boot, Spring with JPA and Hibernate, and more. Here is our table of contents for this talk. First, I will be explaining what Spring is at a very high level. Then we'll talk about dependency injection and inversion of control. We'll talk about Spring beans, bean configuration, constructor, setter, and field injection, and at the end we'll talk briefly about properties files. Okay, so let's get to it. It is helpful to think of Spring as a hash map or collection of POJOs. What are POJOs? POJO stands for plain old Java object. A POJO, or a bean, is simply an instance of an object and is usually created by using the new keyword. So whenever you use the new keyword and create a new object, you have created a bean or a POJO. Spring can be thought of as one big collection of such beans. Spring stores these beans and manages them throughout the life cycle of your application. If you look at this diagram here, these little squares can be each representing a POJO or a bean. As you can see, some of the beans are standalone and are not connected to anything else, and some of the beans are connected to other beans, meaning that they're dependent on each other. So Spring can be thought of as a big container that holds all of the objects in your application and knows which ones are connected to which ones. It knows the dependencies between them and manages these dependencies. So you may ask, how does this hash map idea of Spring help us? Okay, so Spring is one big container and it holds all the objects in my application, but how does this help? Before we talk about that, let's look at an example showing how a class that has a dependency on another class gets defined in the traditional way. Here, to create an instance of the store class, we need to also create an instance of the item class. The creation of the item instance is handled by the store class itself inside its constructor. Therefore, you can see that the store class has a dependency on the item class and cannot be created without it. The disadvantage of classes creating and handling their own dependencies is that A, it makes the code long, complicated, and difficult to follow as the number of dependencies increase. Here we have a simple example with only one dependency, but you can imagine how complicated and confusing the code would get if the number of dependencies were to increase. Also, it's not testable in isolation. You cannot test the code that only has to do with the creation and handling of the store instance itself, as the creation of the item instance is implemented inside the store class itself. It's impossible to separate them. This brings us to the next concept, namely dependency injection and inversion of control. Dependency injection is the practice of extracting all objects that a particular object depends on, defining them separately in their own classes, and passing them back to the class that depends on them when needed. So again, we extract the dependencies, define and instantiate them elsewhere, and inject them or pass them on to the class that needs them when the time is right. Let's revisit the store class again and rewrite it using dependency injection. As you can see in this code block, the instantiation of the item class has been pulled out. It is expected to be defined and instantiated elsewhere and then be passed to our class. Right away, you can see that this code is simpler and much easier to test, as the instantiation of the item class is not done within the store class itself. When testing, we can just mock the item instance and pass it to the store class and test the store class in isolation. We cannot talk about dependency injection without talking about inversion of control, as dependency injection is just a pattern through which inversion of control is implemented. Why is it called inversion of control? Because the control over creating and managing an object's dependencies is taken from the object itself and is given to something outside of the class. In our case, the Spring container is given the control. So as you saw, when creating the store class, we no longer have to worry about creating its dependencies. It expects the Spring container to pass the dependency to it whenever it's needed. Okay, so let's do a quick recap of what we have talked about so far. We described Spring as a container that holds all the objects in our application. We explained how dependency injection can be used to simplify the classes defining these objects. All the dependencies are defined separately, and Spring is expected to inject these dependencies back to the classes that need them. But how does it do that? Spring has three types of injection: setter injection, constructor injection, and field injection. Before we talk about the different ways beans or objects can be injected where they're needed, we need to look at how Spring creates these objects or beans in the first place. There are two main methods by which Spring creates its own beans. One is using an XML configuration file, and one is a Java configuration file. In this talk, we will only talk about Java-based configuration. In Java-based configuration, annotations are heavily used to wire things up under the hood. Annotations are things with the @ symbol. The @ configuration annotation is a class level annotation, which means it's placed on top of a class and is used to mark a class as a configuration file. Once a class is marked with @ configuration, Spring knows where to go in order to find the bean definitions. The @bean annotation is a method level annotation, which means it's placed on top of a method, and it indicates that the method marked with the @bean annotation returns a bean. So whatever the return value of that method is, Spring treats it as a bean. All Spring beans are by default singletons, meaning there's only one instance ever created in the life cycle of your application, and no more. Annotations can be used to change the scope of the bean from singleton to other types, but we won't get into that in this talk. So, to recap, a configuration file which is marked with an @ configuration annotation indicates to Spring where to go to find all the bean definitions. Bean definitions are what Spring uses to create the objects. Now let's look at the three ways that Spring handles dependency injection. Let's look at setter injection first. Here we have a configuration class called appconfig and is marked with the @ configuration annotation. As we mentioned before, when you mark a class with the @ configuration annotation, it indicates to Spring that this is where you go to find all the bean definitions. As you can see, inside the appconfig class, we have two bean definitions, one for item and one for store. The item bean just creates a new instance of item, and the store bean creates a new instance of store. The store bean method first calls the constructor of store class to create a new instance of store, and then it sets the item field. So you may ask yourself, if I'm doing all this work myself and defining the beans this way inside a configuration file, what is Spring exactly doing for me? I'm calling all the constructors myself, I'm creating all the new instances, and I'm setting all the fields myself. Well, Spring is in fact doing something very important. When you call the setItem method on the store, and passing the item bean to it as an argument, Spring does a very important check. It checks to see if the item bean has already been created before. If it has, it just injects the same instance into the setItem method. If it hasn't, it will go ahead and execute the item bean method line by line, and it will create a new instance of item. But if it has an item bean already, it will inject it into this setter. As we explained before, all Spring beans are singletons, and Spring keeps track of that. If a bean already exists, Spring just injects it where it's needed. It won't create it again. Now let's modify our configuration class to use constructor injection instead of setter injection. So we still have our configuration class. Inside we have the bean definitions. We have one bean definition for item and one bean definition for store. But if you notice, we have removed the set item method inside the bean definition for store, and we are just passing the item bean to the constructor of store. Again, Spring checks to see if an item bean exists before creating a new one when creating the store bean. The last method of dependency injection is using the @AutoWired annotation. The @AutoWired annotation can be used directly inside the class defining an object. So instead of using a configuration file and bean definitions and injecting one bean into another, we can inject a bean directly into a class itself. @AutoWired annotations can be used on fields or methods. Auto-wiring is a very powerful tool, and I'll be diving deeper into the different ways it can be used along with other annotations in the future. One important thing to know is that @AutoWired annotation must be used in conjunction with the @ComponentScan annotation, which gets added to your configuration class. As I said, we'll be diving deeper into @AutoWired and its different ways of use in the future videos. Let's do a quick recap before we talk about our very last topic. So we looked at how Spring is a container that holds all of our application beans. We saw where the beans are defined and configured inside a configuration class using the @bean annotation. We looked at the different ways that Spring handles dependency injection. So inside a configuration file, a bean can be injected into the constructor for another bean, or it can be injected in the setter method. And outside of the configuration file, beans can be injected into the classes directly using the @AutoWired annotation. The last thing I want to look at is the application.properties files. Application.properties files are basically files that are made of key value pairs, and it's offered by Spring for further configuration. Let's say we have an application that runs in different environments, and for each environment you have a different set of values that are required. Let's say your application runs in test, development, and prod, and for each you're connecting to a different database. Let's say your database for each one requires a different username, password, and some other credentials. I don't want to be hard coding these values, and every time I want to run my application in a new environment, having to go back and manually update these values. An application.properties file is exactly for such occasions. It's a great way to abstract out values that can change with each environment and separate them from your code. Spring can then look at this application.properties files and inject the values you have set there back into your code using the @value annotation. In the next video, I'll be building a simple Spring application to show you some of these concepts in action and dive deeper into their implementation. Hope you enjoyed this short intro. Before saying bye, I'd like to give credits to Pluralsight's Brian Hansen and Keisha Williams. They offer excellent courses on Spring, which helped me prepare for this video. See you next time.